Dear students, today we will discuss a topic, an important topic of logic. The topic is rules of inference, which is very much important. As you know that there are various rules in deductive logic particularly, and in case of graduation you will find 19 rules as mentioned in the introduction of logic written by M.Copi. Today in this episode we will try to make a discussion on this topic. Some of you are requesting me to make a discussion and try to make the subject easy. First of all, we have to know that Copi mentioned 19 rules, but there are two divisions. In the first division, there are 9 rules, and these 9 rules are called rules of inference. In the philosophy of logic, a rule of inference is a logical form consisting of a function which takes premises, analyzes their syntax or construction, and returns a conclusion or conclusions. This is called a rule of inference. A rule of inference consists of two portions, premise and conclusion, and it is a wholesome process. For example, we may consider the rule of inference called modus ponens, as you know, MP, modus ponens. It consists of two premises, one major premise and the other is minor premise. The major premise takes the form of if P then Q, and the minor premise may take the other form P or Q or something else, curled P or curled Q or something else. And from these two premises we draw a conclusion. So, this process, the total process is called MP or modus ponens. So, actually rules of inference denote a process which includes premise and conclusion. This is the first thing. And the second part which Copi deals is rules of replacement, and in that list you will find 10 more rules. We will discuss those rules one by one, but before that we have to know something about these rules of replacement. A rule of replacement is a transformation rule that may be applied to only a particular segment of an expression. Of a total expression, we can apply these rules only to a particular segment. A logical system may be constructed so that it uses either axioms, rules of inference, or both as transformation rules for logical expressions in the system. Whereas, a rule of inference is always applied to a whole logical expression. A rule of replacement may be applied only to a particular segment. This is the main difference. Within the context of a logical proof, logically equivalent expressions may replace each other. You will see the use of triple bar or equivalent sign, and in the left part there will be one expression, and in the second part there will be another expression. And in case of these rules of replacement, one part may be replaced by the other part. This is the another distinction, another distinctive features of logical rules or rules of replacement. So, now come to the rules. One by one we will try to explore these rules, and in the coming episode we will try to demonstrate the use of these rules step by step following Copi. You can see in the screen that there are rules of inference, and almost all the rules are very much known to you. First one you can see modus ponens MP, and the second one is modus tollens or MT. These are the two subdivisions of hypothetical syllogism. Hypothetical syllogism. In the first MP form, you can see P implies Q. If P then Q, it is symbolized as P implies Q, and this is the major premise and P is the minor premise, and from these two we are drawing the conclusion Q. Similarly, in case of MT, the major premise is same, P implies Q, it means if P then Q, and in the minor premise the consequent is negated, and from these two we are drawing the conclusion curl P, that means the antecedent is negated. In this way we are getting these two rules from hypothetical syllogism. Third one is hypothetical syllogism. As you know, hypothetical syllogism is divided into two types, mixed hypothetical and pure hypothetical. This third one is called pure hypothetical syllogism. Copi mentioned it as hypothetical syllogism or HS. In the first premise, P implies Q. In the second premise, you are getting Q implies R, and from the combination or joint application of these two premises, we are getting the conclusion P implies R. In these two premises, you are getting one thing common, that is the consequent of the major premise and the antecedent of the minor premise. These two are same, and this term actually is making the bond, making the relation between the two premises. So, this feature is to be considered while making use of this rule. Fourth one is called disjunctive syllogism. This actually is the application of disjunctive syllogism, as you know. And in the rule we can say that in the minor premise we can deny one disjunct, and in the conclusion we have to affirm the other disjunct. So, P vel Q, either P or Q, and in the minor premise we are seeing that the first disjunct is negated, and in the conclusion we are seeing that the combination, from the combination of these two, the conclusion is drawn Q. Now, come to the next rule, constructive dilemma CD. This is something new, or we can say that it is not at all new, it is the joint application. It is the joint application, and let us explain why I am saying it is a sum total. It is a sum total of two MPs. In this rule you are saying within first bracket P implies Q dot within first bracket R implies S, and in the minor premise we are getting P vel R, and in the conclusion we are getting Q vel S. Now, just try to intersect, try to divide it into two parts. First part is P implies Q in the major premise, and in the minor premise first part is P, and in the conclusion first part is Q. So, now consider P implies Q, P therefore Q. You will see that this is the application of MP, just simply MP. And similarly, if you can divide the second part separately, you will see R implies S. So, R is the antecedent, R is affirmed, and then S is affirmed. So, this is another application of MP. Just to for reminding, you have to consider that in the major premise we are using dot sign between the two, and in the minor and in the conclusion we are using vel sign. So, this is called constructive dilemma, constructive dilemma. Now, come to the next rule, that is called conjunction. Conjunction. This is very much simple. If we get two statements P and Q, we can just conjoin these two statements by using the symbol dot, dot or and, P and Q. This is nothing more. Simplification, just opposite to conjunction. If we get a conjunctive proposition P dot Q, from P dot Q we can just simplify P. This is nothing more. This is called simplification or sim. Now, come to the next rule, absorption. Absorption, P implies Q. P implies Q, from P implies Q we can say that P implies first bracket P dot Q. P implies Q, from this we can say that P dot Q within bracket P dot Q. These are the 9 rules, these are the 9 rules and these rules are called rules of inference. And what I have said that this actually involves a procedural thing. That means, we can draw a conclusion from the application of one premise or more than one premises. Now, come to the second part, which is very much important. This is called rules of replacement. Rules of replacement, as we have said that this can be applied only in case of a segment or part, and one part can be replaced by the other. First one is De Morgan's theorem. De Morgan's theorem. De Morgan was a logician and according to his name this rule is placed. In De Morgan's theorem, it is said first curl first bracket P dot Q equivalents to first bracket curl P vel curl Q. It has got another form. It has got another form. In the second form, you can see curl first bracket P vel Q first bracket close equivalence to first bracket curl dot curl Q first bracket close. So, just in case of these instances, we are getting the opposite uses of symbols. In the first one we are getting dot is becoming vel, and in the second place we are getting vel is becoming dot. Rest of the portions are same. So, if you get curl first bracket P dot Q, you can use it in the process of logical deduction first bracket curl vel curl Q, you can use it. So, one part can be replaced by the other part. The next one is called commutation. One part can be commuted by the other. P dot Q triple bar or equivalence to Q vel P. It has got another version P dot Q equivalence Q dot P. One variable is taking the place of another variable, just changing the position. No symbol is changed in case of this rule. This is called commutation. Next one is called association. In this rule, the use of bracket is very much important. It has got two forms also. In case of this first one, you can see all symbols are vel symbol. And what changes are taking place? Only brackets are changing their positions. In case of the left part, you can see the first bracket is in between Q and R, and in the right part you are seeing that the first bracket has come within the scope of P vel Q. So, in case of this rule, the place of the bracket is only changing. Same is true about the second version of association. Next one is distribution. In case of this rule, you can see that third bracket P dot first bracket vel Q vel R, first bracket close, third bracket close, equivalence to third bracket first bracket P dot Q first bracket close vel first bracket P dot R first bracket close, third bracket close. So, actually in the left part we are getting two portions, P is the first portion and the second portion is Q vel R, and P is distributed with these two portions of the or sub portions of the second portion Q vel R. That means, in the first part Q is taking the position of P is taking the position of Q with its sign dot, and in the second portion P is taking its position with R with its sign dot. So, the main sign is dot, and in the second version also you are seeing that P is taking the position of Q and R with its sign vel. The main thing in this rule is in the left part the sentence is actually a conjunctive sentence, and in the second part the sentence has become a disjunctive sentence. And in the second version the left part is a disjunctive sentence and the right part the sentence is a conjunctive sentence, but these two are equivalent, one part can be replaced by the other. Next one is double negation. This is very simple. P equivalence to curl P, one part can be replaced by the other. Next one is called transposition or transposition. P implies Q equivalence to curl Q implies curl P. Next one is called implication. Next one is called implication. P implies Q equivalence to curl P vel Q, curl P vel Q. Next comes equivalence, equivalence. P equivalence to Q. This is the left part, and in the second part you are saying that in the first part P implies Q within first bracket dot Q implies P within first bracket. This is the first version, and in the second version you are saying P dot Q vel curl P first bracket curl P dot curl Q. And these two portions, if you try to make the two portions related, you will find that P dot Q vel curl P dot curl Q can be reduced into P implies Q dot first bracket Q implies P. Next one is called exportation. Exportation. P dot Q first bracket curl R equivalence third bracket P implies first bracket Q implies R first bracket close third bracket close. Next one or last one is called repetition. P equivalence to P vel P, or the second version is P equivalence to P dot P. One part can be replaced by the other. So, these are the 19 rules. Again I am saying that first 9 rules are called rules of inference, and the second 10 rules are called rules of replacement. One part can be replaced by the other. In the next episode we will start how these rules are applied step by step. If you go through the book of Copi, An Introduction to Logic, you will find Copi has clearly or very lucidly stated different examples. In some examples he has put some questions in which you will just use 2 steps and then 3 steps. In this way, step by step method of deduction are applied. So, I think you will find interesting, and in the next episode we will go to the next part. Just put your comment in the comment box, how do you like it, and you will be very surprised how or why I am giving this video in English version. Some of you are writing me to give subtitle, because unfolding philosophy has reached students who are actually studying in English, and it has gone to beyond West Bengal. So, that is why sometimes I have to give some episodes in English, or sometimes I will have to give the episodes in bilingual methods, so that those students who are studying really in English, they can take the benefit of these discussions. So, for this today's discussion, I am ending the episode. Hope this will become helpful to you.